In this lesson, we are going to learn how to find the average atomic mass of an element from their given isotopes. In this case, the formula for finding the average atomic mass is basically the sum of the mass number times the relative abundance of that isotopes, and we continue to add the mass number times the relative abundance of another isotope until we finish adding all the isotopes together. There are two steps. The first step is to convert all the given abundances to decimal. If you are given percentage, you divide by 100 because percentage is out of 100. Or you can convert into a fraction if you are given as a ratio. That is, you're adding all the part of this ratio together to get your new total. And the second step is to use the formula, which is given to you here. All you have to do is substitute in the values. In this case, let's do an example problem. We have hydrogen element has 99% of hydrogen 1 isotopes. We have 0.8% of hydrogen 2 isotopes. We have 0.2% of hydrogen 3 isotope. Calculate the average atomic mass of this hydrogen element. So first of all, it is given to us in percentage, so we have to divide this by 100 to get our relative abundance in decimal. So let's look at the solution. Here I have isotope hydrogen 1. I take 99% divided by 100, and that will give me 0.99 times the mass number, which is given to us right here, and give us 0.99. Then for hydrogen 2, we would have 0.8% divided by 100, give us 0.008 times the mass number again, give us 0.016. Then we have hydrogen 3, we have 0.2% divided by 100, give us 0.002 times the mass number, which give us right here, give us 0.0016. And then we add all the masses together, that gives us a total mass for hydrogen. In this case, 1.012 AMU, or AMU stands for average atomic mass unit. Now, if we look at the periodic table right here, this average atomic mass of hydrogen is the same one as this one that we just calculated. Therefore, we can identify an element based on the average atomic mass. Therefore, we can identify the identity of these isotopes based on the calculated average atomic mass. Let's do an example where we have the ratios instead of percentage. In this example, we have gold, represented by the symbol Au, has two isotopes, Au-197 and Au-198. First of all, we have gold has two isotopes, Au-197 and Au-198. Both isotopes are found in a ratio 1:1. That means then calculate its average atomic mass for gold. Going back to the formula, we have the formula as average atomic mass is basically the sum of the mass number times the relative abundance of all the isotopes. But you have to do them individually. In this case, we don't have decimal, but we have a ratio. So we had to add all the parts in this case. So if we look at the part of the ratio, we have 1:1 ratio. In this case, there are two parts. One part is 1, the other part is 2. So 1 plus 1 gives us a total of 2. Your total now is not 100 like percentage, but it is 2. So how is that going to work? In this case, we have the isotope Au-198. So we convert that into a fraction. Our total now it is 2. This is the part of the ratio. So it's 1/2 give us 50%, which is 1:1 ratio that we get from here. And now, in this case, so we have a fraction for this isotope. So we have the mass number given to us right here, times the fraction, which is 1/2 or 50%, give us 99. And then we have 197, again, the part is 1, so it's 1 over the new total, give us 1/2. You take the mass number right here, times the fraction, give us 98.5. Then we add all the masses together, give us 197.5, and we compare that to the periodic table of gold, which is 196.97, or about 197. Basically, again, we can find the identity of an isotope if it's not given to us by calculating the average atomic mass from the given information about their isotopes.